Okay, complex numbers. Tell me what you want to do. Huh, really? You want to move that part of your Cartesian. Oh, that's a good point. That means you want to learn the other forms.
Like what?
Trigo, polar form? No, right? That's the most level one, right? Actually, it all makes sense, one.
Tangent inverse V over A.
Ah, yeah, that's the modulus argument, right? Later I tell you more. That one is for later. Anything else you want to add about complex numbers? I. Okay, good. That is the main crux of this chapter, right? I squared equals negative 1. Okay, so why do we need this? Your teacher, Karen? Number 2, what is I to you? Imaginary, what else? No, it's not like an x. Because if you see it like an x is a variable. It is constant. It's a constant, and I'll tell you why. Let's go back to Sec 3. You'll be hearing this a lot. I tell you go back to Sec 1, Sec 2, Sec 3. So Clara, I remember damn clearly I taught you this in school when you were in peers, right? When we were doing quadratic equations. I distinctively remember when I taught you completing a square, I asked you from Sec 2. From Sec 2, what are the different ways to solve a quadratic formula? Sorry, quadratic equation. In Sec 2, what did you learn to solve?
Completing the square.
That's Sec 3. That's why I said that when you were learning completing a square.
The table.
Yes, multiplication frame. So you draw the bracket, right? But that counts on the fact that the numbers are whole numbers, right? What else, Nicholas? Sec 2 also.
Graph.
Good. Correct. Graph. Carrie, it's your turn. Now you can move on to Sec 3. Yes, that's not wrong, but that actually came from the decimal point came from
The formula.
correct quadratic formula, which also derives your completed square form. So this is your quadratic formula. So back then, a very long time ago, we learned a lot of math, right? So for example, Nicholas, Pythagoras theorem, who is it by?
Pythagoras.
Yeah, Captain Obvious, right? Maclaurin series? Harris, Taylor series? Taylor. But you can find out. But you realize certain math concepts, there are no names. Right? For example, Pythagoras theorem came up with the triangle, he wanted to credit himself, that's why it came up with the name. But then things like differentiation, integration, but no name, that's a different issue. But complex numbers is one of those things that do not have a name. And why is that the case? Because let's say today, Nicholas, you're the president of Taekwondo, right? So let's say I want to become a Taekwondo president. What do I have to do?
Really good.
Interview, right? Then probably have to do some performance, whatever, right? Like show my moves and all that, right? But back then, when they were doing math as a professor, if I wanted his job, I'll just go to Nicholas and say, I challenge you to a duel. So literally, Nicholas will turn around, I turn around, I set 10 questions, he set 10 questions, we exchange. Then we solve the question. And if you cannot solve my question, you are therefore out of a job. Then you just move on. Complex numbers actually came from here. Which is that a question, a quadratic equation that nobody can solve. Any of this, it doesn't work. And that's why people are losing their job. How did it come about? So let's say I go to my Sec 2, x squared plus x plus 1. Number one, if you do your discriminant test, you should get a real root, right? But now let's say if I apply my quadratic formula, x equals to, the formula is negative 1 plus minus square root b squared minus 4ac over 2. From here you get negative 1 plus minus square root of negative 3 over 2. At this point, most people get stuck. And that's why Nicholas lost his job and got his job. But then obviously Nicholas will be unhappy, right? Just because you show me, just because I don't have an answer, doesn't mean that you have an answer. So I will have to show you the answer. The answer came from here. Which is that, because the negative is something I cannot square root, I'll just make it negative 1 plus minus of square root 3i squared over 2 equals to negative 1 plus minus of square root 3 I over 2. Then why do we call this imaginary? Any idea? Why? How do I know that it doesn't exist? Because, like Nicholas said, if I draw a graph, it's not there. Imaginary. But then Nicholas will say, hey, just because you prove that you can solve, how can this be the answer? We just draw the graph, it doesn't make sense. There's no root. I, as a professor trying to take his job, I'll say, you know how I know this is an answer? Just like in your trigonometry identity. If I prove that left hand side equals to the right hand side, it must be the same thing. That's why he said, you know what, you don't believe me? You sub in z minus negative 1 plus square root 3i, then z minus negative 1 minus square root 3i. You expand it, you get back here. Therefore, this is still an answer. Do you realize this feels very familiar to something we've been doing in history math? Substitution. That's all we're doing. And that's why I keep telling you all in history, stop checking the camera. Don't break the fourth wall. You know what's the fourth wall?
No.
When you act, there's only like 3 walls, right? If you look at the camera, you're breaking the fourth wall because there's a fourth wall there. You must pretend it doesn't exist. Right? See, now I have the cut. Anyway, so now, what am I trying to say over here? Number 1, this is a form of substitution. Number 2, it's imaginary but it's an answer. Because what does it mean when an answer is, if I can get the solution, I can prove back the question. It must be an answer. That's just how math works. But can you see it on the graph? You cannot see it. Imaginary. And the second point I'm trying to illustrate to you here is what Clara said at the very start. I is a constant. Whenever you try alphabet, whether it's a constant or variable. And that will be the only learning objective for the first half of the complex numbers. It is constant. Why is that important? When you see an I, let's say I got simultaneous equation z I plus I minus 2 w equals to 1. Then it's z minus 3 w equals to 4. Very often I told you that we don't like to do substitution. Because if I do substitution, I make z the subject, even, okay, in this case not so bad, I make z the subject, this one is like 4/3 w. But in other questions, let's say there's an I over here, you make z the subject, you get a fraction with an I at the denominator. This is known as irrational number. Just like your cert. Again, what's my point? I is a constant. That's why you do rationalization. It is a constant. Right? Number 2, because I understand I is a constant, when you see this, you see as IZ I minus 2. All I see is constant Z, constant W minus equals to 1. And therefore, I can just take this equation and then multiply by I. Then this whole thing will become IZ minus 3IW equals to 4I. I do my elimination. Again, all I'm trying to say is I is a constant. And this will be the recurring theme throughout, from polynomials to what else? Mainly polynomials, because I use the word just polynomials. I can prove to you. Very simple stuff. It all came from here. But that will be for next week. On to it. I got a lot of stories to tell from this topic first. I can. Did your teacher prove to you contrary root theorem? Did he tell you why that's the case? No?
No.
That's just telling me the condition, right?
That's not the lecture notes.
I'll tell you why. Then you can slap the teacher back in the face as to by using this story. The answers are all here. For the next few weeks, you'll just be looking at this. From here, we can derive a lot of things. Just like this duel between me and Nicholas. That made our job. So Nicholas took this, right? He understand already, go to the next person. Then you put the other person out of job. And that's why complex numbers doesn't have a name. It was a secret to people. That's why certain theorems in the world don't have a name. But nowadays all got names because they want to memorize. Okay? So to illustrate that, let's just do one very simple simultaneous equation.
Why?
Yeah, just question 1, that's all. Yeah, question 1. Quick pause. I have a special announcement for the JC1, JC2 and the Sec 4 students. I will be running a free trial class during the March holidays for the JC1 and the Sec 4s in H2 Math and Chemistry. Now that school has started, some of you are already struggling to catch up, and you look at what you've seen on Reddit, a lot of people are struggling, and if you're looking to attend tuition that is not a chore, where you get to listen to stories and therefore help you understand better about many concepts and how they came about, so that when you go to the exam hall, you do not second guess yourself and you're fully confident in your H2 Math and H2 Chem, even if the paper was the easiest ever. Scan this QR code, contact me, and I'll see you there.